writing linear functions from word problems. We'll have two examples. The first one says a young sumo wrestler decided to go on a special high-protein diet to gain weight rapidly. He started at 90 kilograms and gained weight at a constant rate. After 8 months, he weighed 138 kilograms. Let W represent the sumo wrestler's weight in kilograms after T months. And we are supposed to complete the equation for the relationship between the weight and the number of months. So I notice there's some information that's given. And the information is related to the two variables. And the two variables are going to be T, which is the number of months that have passed since the sumo wrestler has begun this high protein diet, and W, which is his weight in kilograms. And what I like to do is I like to look for a couple of ordered pairs. And if I fill the ordered pair information into my table, it can help me figure out what is the initial value that's given in the problem, or what is the rate of change that is being described in the problem. Now, for this particular problem, we know that he started his diet, so 0 months in, he weighed 90 kilograms. So what's nice is that when we have a linear function in the form y equals mx plus b, where b is the initial value, right, it's your y-intercept, that has been given to me here. I do know my y-intercept. What I don't know is how much weight he's gaining each month, but it tells me two things. One, that he is gaining weight at a constant rate, so I know it's some kind of a linear function, but also that after 8 months he weighed 138 kilograms. So when I think about my typical slope-intercept form, which is going to be a nice form to use here, y equals mx plus b, I do have my b. I have my initial value of 90 kilograms. I don't have my slope, my rate of change, but I can figure that out by doing the change in y over the change in x, right? Or the change in weight in this case, which is 48 kilograms, to the change in t, which is 8 months. And so when I love this change in y over change in x to find my rate of change, or my slope. It's just 48 divided by 8, which is going to be 6. So I can now figure out that my slope, my rate of change, is 6. And this would be the equation, except they've given me other variables. They've given me W for my dependent variable and T for my independent variable. So I want to type in W equals 6T plus 90 to represent this relationship. So notice in this case, in the word problem itself, I could tell that the initial value was given and I needed to figure out my rate of change. Okay, so in the next example, it is going to be the reverse. Let's read it. Carolina is mowing lawns for summer job. For each mowing job, she charges an initial fee, right, which is some unknown initial fee, plus $6 per hour of work. That's my rate of change. Her total fee for a 4-hour job, for instance, is $32. Now, F is going to represent Carolina's fee. That's my dependent variable in dollars, for a single job that took T hours for her to complete, and I'm going to write an equation. So once again, I love to start with a table. It just seems to simplify the information that's given in words. My independent variable is T in hours. That's the number of hours she's working. My dependent variable is F, which is the fee that she's earning in dollars. 0 hours in, her initial fee. We don't know what that is, so I have to leave that blank for now. But I do know that a 4-hour job, she charged $32. So now let's think about our slope-intercept form of a linear function. In this case, which of those two am I given? Do I know the rate of change or do I know the initial value? Well, I don't know the initial value, right? Because that's her initial fee, which is not given. But I do know that her rate of change is $6 an hour. So now my job is to figure out what is the initial fee. And so, once again, thinking about slope as change in y over the change in x, I can actually see my change in x, right, which is 4. I don't know my change in y, but here's what I do know. I know that change in y over change in x is 6, right? That's given as 6. So really, the question I would ask myself is, what number divided by 4 equals 6? Well, I know my change in y has to be 24, right? 24 divided by 4 is 6. So if in fact my change in y is 24, then what fee did I start with at 0 hours, which when I added 24 to it gave me 32? That would have to be $8 is the initial fee. So now I have my slope-intercept form of the equation. I just need to use the variables that are given to me in this problem. So f then is equal to 6t plus 8.